Alright, so in this video I'm gonna explain the implementation of checkmate finding checkmate in a certain amount of moves in chess using backtracking and depth limited search algorithm. So we have two functions here, get answer move and its opponent cannot escape. So we start from get answer move with a known a number of moves that is needed for the analysis. So we iterate all the legal moves as answer move candidates. So each move from that we execute it to the board, to the game state that we received as a puzzle chess game. So we then check after executing that move. We check whether the opponent can escape or not. So if the opponent cannot escape, then we return that move as the answer move. If if it can, if the opponent can escape, then we have to search other move from the legal moves as a candidate. So the candidate move itself can be accepted or rejected as a answer move. The implementation of uh, deciding whether the opponent can escape or not is we check whether any legal move available or not for the opponent. If it's not, then it will be either stalemate or checkmate. So we return true if checkmate, so that means the opponent cannot escape. But if it is a stalemate, so it is a draw. It's not a win for us. So it will return false. So if there is no legal move available, so we return king, whether the opponent's king is attacked or not. Alright, so if there is a legal move available, then we check whether the number of moves we are checking is equals to 1 right now. If it's equals to 1 and it is not a checkmate, so there is a legal move available, so that means the opponent can escape from the checkmate. So we return false. But if the number of moves is greater than 1 and there is a legal move available, that means we have to check every legal moves from the opponent pieces and we execute it we iterate for all the legal moves and we execute it to the board, to the game state, and then we get the answer move, the counter move, whether it will lead to a checkmate or not. It's like a recursive from the get answer move. We check whether the opponent can escape or not, and then we check again whether the next move is leading to a checkmate or not. So if the answer move is not available, it's not there, that means the opponent can escape. So that means we return false. But if we pass all of the legal moves from the opponent pieces, we passed all of that, so we return true. That means the opponent cannot escape. So the best recursive is whether it's a checkmate, a stalemate, or the opponent can escape. So that is the pseudocode for the implementation. Let's check for the illustration here. Okay, for example, in this graph, the amount of moves we will analyze is 2. So the depth for the depth limited search is 2 for each our move. So we choose a random candidate answer move from a starting game state from the chess, and then we check whether it is an accepted move or not. If it is an accepted move, just like this one, then it is the answer that we're looking for. We won't we won't have to search for another candidate answer move. We can just choose this one. But if it is a fail one, like this one, then we have to find another candidate answer move. Then we check again whether it's unaccepted or not. So for example, an accepted move here, we choose a candidate answer move. Then after we execute it to the board, to the game state, we check every possible opponent move. For example, this one. So we iterate for each opponent move. Then each opponent move itself, we find a candidate answer move. We find an answer that is leading to a checkmate. Then, for example, for the first move we choose, it's leading to a checkmate after 2 def. That means for an opponent move to note 3, it will lead to a checkmate. It is a success then. But we have to check for every other opponent move. Then, for example, we check for note number 5 here, from an opponent move to note number 5. We check that it will lead to a checkmate for a certain answer move. Then we check again for another opponent move that leads to number 7. For example, we choose a random candidate answer move and it leads to not a checkmate. It's fine, so we have to find another candidate answer move. So at least candidate, at least for each opponent move, we can answer it for at least one answer move, one unaccepted answer move. For example, this one, note number 7, has at least one answer move that is leading to note number 9, that is leading to checkmate. And then we check another opponent move again, and it leads to note number 10. And we check again, we're finding a candidate answer move. Then it, for example, to this note number 11, it leads to no checkmate. And then we are searching again for another candidate answer move, and it leads to not a checkmate. Then we find again, and for this one, a candidate answer move this leads to a checkmate. That means an opponent move to note number 10 is leading to a checkmate if we choose this and candidate answer move. That means every possible opponent move, for example, this one is there are only 4 opponent moves. So every possible opponent move that the opponent can make, we can lead them to a checkmate. If the opponent make a move to note number 3, then we can checkmate them to note number 4. If the opponent move to note number 10, then we can checkmate them to note number 13. So a candidate answer move can be proven to be the answer move if both of the condition is fulfilled. That is, 1, for every possible move the opponent makes, there is at least one answer move that can lead to a checkmate. And then, or a candidate answer move is accepted if the direct next move is the opponent is checkmated. So this one is accepted because the next move is not available for the opponent and it is a checkmate. And then this one, a candidate answer move, this is accepted because every possible opponent move is will lead to a checkmate, just like I explained before. So this is a case for an accepted candidate answer move. That means we can choose this answer move to the puzzle, to the chess puzzle. And then this is a case where the candidate answer move is not accepted and it is failed. So after we choose the candidate answer move, we check every possible opponent move, just like before. But in this case, there's one opponent move that can escape from the checkmate. That leads to node number 10. So this one, when the opponent move, choose the move to node number 10, we don't have any answer move that leads to checkmate. After the given amount of depth, that is 2. So after the depth 2, there is no checkmate found. So after the opponent make a move to node number 10, we find every possible candidate answer move, and every one of them leads to no checkmate. That means the candidate move is a failed one. This one that we choose is failed because it 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 gives the opponent a chance to escape from the checkmate, that is move from node 2 to node number 10. So if the candidate answer move is failed, then we have to find another possible candidate answer move, and we check again whether it leads to a checkmate or not in a given amount of depth. Alright, so we can test the algorithm to a given puzzles. So I found this one from chess.com, from the forums, from Triple X Doom. There is a puzzle checkmate in 2 moves here. That means the depth will be 2. So we have to find a move that will lead to a checkmate for the given opponent. So I implemented this with Java. So we give the input number of moves is 2. And then we give the chessboard state in a fan notation. Let's see, we can get them from this and paste there here. Alright, answer found in 300 milliseconds. So the algorithm gives a move d5 g8. That means from a board coordinate d5 move to a board coordinate g8. That is d5, the queen, my queen, move to g8, this one. And it is a correct move. And then the opponent make a move that is rook from e8 to g8. So we can write this down here, e8 to g8. And then the algorithm suggests to move h6 to f5. h6 to f7. h6, yeah, that is my knight, to h7, this one. And then yes, that is a checkmate. The king cannot go nowhere, and the knight cannot be stopped. That is solved. And that was 2 moves from me. That means it can be checkmated in 2 moves. So let's try another one here. Let's run this again. Alright, so this is the same. That is checkmate in 2 moves. So let's input this too. And the fan notation, we can download it here. Alright, answer found in 130 milliseconds. So the algorithms suggest to move d5 f6. d5, so d5 is this knight to f6, to this one. Alright, so the opponent counter move with the queen from d8 to f6. So let's write this, d8 f6. Alright, so the algorithm gives a move h6 to f8. h6, that is my queen, to f8. This one. And then yes, that is a checkmate, and it is solved. It's the checkmate because if the opponent's rook takes my queen, then my bishop can attack the opponent's king, and the king itself cannot go anywhere. That will be a checkmate. Alright, so that is the example of the puzzle checkmate into moves. Thank you.